we are going to start our fourth lecture of class 9th mathematics chapter 1, the number systems. In this lecture we will talk about the irrational numbers. Earlier we have studied natural numbers, whole numbers, integers and rational numbers. Now the next definition we have is the irrational numbers. So in the previous lecture we have seen the definition of rational number, and the definition was the number which can be expressed in the form of p by q, where p and q are the integers and value of q is not equal to 0. This was the definition of rational number. Then we have seen the decimal representation. So in decimal representation we are saying there are two kind of representation for rational numbers. One is the terminating decimals and the second is non-terminating but repeating. So rational numbers are having the decimal representation, either it is terminating or it is non-terminating but repeating. Now if suppose I am talking about a number, say I am writing a number, it is 0.01, then it is 001, then it is 0001, then it is 00001 and so on. So this is also a number we are writing in the decimal form. This is the decimal number we are writing. So what is happening over here? We cannot write it like 0.01 bar because it will become 0.010101 and so on. I cannot, there is no repetition like this. It seems like that zeros and ones are there, but what is happening over here? These are 2 digits, then these are 3 digits, then these are 4 digits, then these are 5 digits. Similarly, suppose I am talking about a number, say 0.54554, then 555, it is 3 times, then 4, then 4 times 5, then 4 and so on. So there is no fixed length which is repeating. You suppose I am writing any number randomly, suppose it is 0.12478628776. There is no repetition over here. That number digits are not repeating after a certain length. Then these kind of numbers, these kind of representation, these are called the irrational numbers. So the definition of irrational number we have is a number which can neither be expressed as a terminating decimal nor as a repeating decimal is called a irrational number. So some examples are given over here and we will discuss these examples in details in our next slides. So the first kind of examples we have already discussed, that these are the numbers in which the numbers, this is 0, 1, then 3 digits are there, then 4 are there, then 5 are there. Similarly in this it is 1, 2, then 1, 1, 2, then 1, 1, 1, 3 ones are there, then 4 ones are there. So the terms are not repeating. The next type of numbers we have are the square roots. Suppose I am talking about square root 2, square root 3, square root 5, square root 6. So all these numbers we will see for the proof of these numbers. We will see the proofs in class 10th. But these are some basic definitions over here. We are saying that if I am talking about square root 2 and I calculate the value of square root 2, it will keep on going like this. It will not repeat after certain steps. It will, we will get next and next digits, but there will not be any repetition over there. Similar is the case with square root, cube root of 3, cube root of 2. These definitions we will see in our next slides also. Now for more details or for clarity purpose, I have shown the calculations of square root 2 over here. So when we calculate square root 2, how we are starting it? It is 2 over here. We will see some steps over here. We start with 1. So we are saying it is 1 and the answer we are getting, it is 1. The remainder left, it is 1. So Now we put decimal over here. So what we get is, it is 2 zeros over here. These 2 zeros comes over here. So 1 is there. So now from this 1 we are getting over here, it is 2. So next step is, it is 24, and over here we are getting it is 4, and the answer we are get 24 into 4. This step in this, what we are going to do, 24 into 4, the answer you will get it is 96. The remainder we are left with is 4. Now again we will get 2 zeros over here, and the double of this number is 28. Now it is 28 1. So what we are going to do, 281 into 1, the answer is 281. So what we are left with over here is 119. Now the double of this number we have to carry forward over here. So it is 282. Now the next digit will be here, it will be 4, and this is 4 over here, and the answer we are getting it is 11296, and the remainder is 60400. Likewise, if we will continue, what we have seen, it is 414. Now this 4 is already there. What we are saying is, if the remainder is same, even in this case the remainder is same, it is 4 over here. You suppose after some steps again you will get the remainder as 4. It is not necessary that the digits will start repeating over here. You can see these calculations at your own. You can do this, try these calculations to see that the digits are not repeating. We are getting the numbers in the form 1.414235, and if you keep on calculating these values, this will keep on going like this. Similarly, if we look at the value of pi, we are saying, if you look at the value of pi, then the value of pi is 3.14 and so on. It will keep on going like this. But what we assume is, we assume that the value of pi is 22 by 7. It seems like what we see from this is 22 by 7 is in the form of p by q. So it should be a rational number. If it is this, then it should be a rational number, but pi is not a rational number. This is just a representation. Or what we are saying, this is just an approximation of pi for calculation purpose. This is not the exact value of pi. 22 by 7 is not the exact value of pi. If you calculate the value of 22 by 7, it will match with pi up to certain digits. It is not the exact value of pi. So pi is an irrational number. This thing you have to keep in mind, that pi is irrational. Its approximation is 22 by 7. It is not the exact value. Now next we have certain properties of irrational numbers. So we are saying that irrational numbers, they satisfy the commutative, associative and distributive law for addition and multiplication, just like the other numbers. If we are talking about the rational numbers, they also satisfy this. So commutative law means, we are saying that if we take two rational numbers and we are talking about addition, then it is a plus b will be equal to b plus a. Then if we are talking about associative, it means a plus b plus c, that will be equal to a plus b plus c. That is, you add b plus c, you add a to it, or you add a plus b and then add c to it, you will get the same answer. Similarly, they will satisfy for the multiplication, that ab is equal to ba and a into bc is equal to ab into c. And if we talk about the distributive law, it is a into b plus c, that is equal to a into b plus a into c. So these, the irrational numbers, they satisfy commutative law, associative law and distributive law for addition and multiplication. The next result we have is, the sum of two irrational numbers need not be an irrational number. So this is an interesting result over here. If we are saying, if we are having two rational numbers, it is 2 by 7 plus 3 by 4. The answer you will get, it is always a rational number. But if we are having two irrational numbers, I am talking about 2 plus square root of 3, and second irrational number is 4 minus square root of 3, then what we are saying, if we add these two numbers, then these two gets cancelled and we are left with answer as 6, which is a rational number. What we are saying, that these two numbers, these are irrational and this number is a rational number. Similarly, if we take the difference of two irrational numbers, it is not necessary that answer is always irrational. The example is given over here, that the two numbers are given to us, 5 plus square root 2 and 3 plus square root 2. If you subtract these two numbers, the answer you will get it is 2, which is not a irrational number, it is a rational number. Similarly, if we multiply two irrational numbers, it is square root 3 into square root 3. The answer you will get, it is 3. It is a rational number. We are not saying that this is always the case. If suppose I am multiplying square root 3 and square root 2, the answer I will get, it is square root 6. This is an irrational number. But if I am multiplying square root 2 and square root 2, I am getting the answer is 2, which is a rational number. So we are saying that it is not always necessary that if we multiply two irrational numbers, then the answer will be irrational. It may be rational, it may be irrational. Similar is the case with the division. So we are saying, if we divide these two numbers, 2 root 3 and square root 3, the answer we are getting, it is 2, which is a rational number. Now the next result we have is, the sum of a rational and an irrational is irrational. So if we talk about the example over here, we are saying a rational number is given to us, an irrational number is given to us. So overall this number is irrational. Similarly, for the difference, it is 4 minus square root 2. Similarly, 4 square root 2. Similarly, 4, you can write it like 2 over square root 2 over 4, or you can write it like 4 over square root 2. So all these numbers, these are irrational. So we are saying, if we add, subtract, multiply or divide rational with irrational number, the answer is irrational number. In the previous slide we have seen, if we add two irrational numbers, it is not necessary that the answer is irrational. It may be rational, it may be irrational. But if we are adding, subtracting, multiplying or dividing irrational and rational numbers, then the answer is always an irrational number. So this thing is given over here, that if a is a rational number and square root b is an irrational number, then all these numbers, these are irrational numbers. This is mentioned over here. Now, in the previous lectures, we have seen that if we have to find a rational number between two numbers, a and b is given, two rational numbers a and b are given, which are positive numbers, then the procedure is a plus b by 2. That is, a plus b by 2 is a rational number lying between a and b. What we have done is, suppose 3 and 7 is given to us, we have to find another rational number. We are saying we write 3 plus 7 by 2. So the answer you will get, and that is the number that is lying between 3 and 7. If we have to find irrational number between two rational numbers a and b are given, both of these numbers are positive. This is important over here because radical sign is there. Radical sign means this square root I am talking about is there. So we are saying both these numbers, these are positive, and Suppose 3 and 7 I am talking about, and I have to insert an irrational number. So answer will be square root of 3 into 7. So that is an irrational number between these two rational numbers. So for to insert a rational number, the formula is a plus b by 2. To insert an irrational number, the formula is square root of ab. But it is important to note over here that both a and b are positive rational numbers. This point is very important over here. So now we have a question over here, that are all the square roots of all positive integers rational? That is, we are saying that square root of 2 is irrational. Square root of 3 is irrational. But if we talk about square root of 4, the answer is 2, which is rational. So what we get is the square root of every positive integer is not always irrational. It may be rational, it may be irrational. Now the next question we have is, are the cube root of all positive integers irrational? Again, same thing is there. If I talk about cube root of 2, then the answer is this number is irrational. If I am talking about cube root of 3, it is irrational. Cube root of 4, it is irrational. But if I am talking about the cube root of 8, it is rational. That is, the answer is 2. So this number is a rational number. So what we get is that the cube root of a positive integer is not always irrational. Next question we have is, insert a rational and an irrational number between 3 and 4. So to insert the rational number, the formula is 3 plus 4 by 2. The answer is 3.5. To insert the irrational number, the formula is square root of a into b. 3 into 4. So the answer you will get, it is square root of 12. So this number is a rational number between 3 and 4, and this number is an irrational number between 3 and 4. Next is, find two irrational numbers between 1 by 7 and 2 by 7. So one method is that what we can do is, we can write 1 by 7 into 2 by 7 square root. The answer you will get, it is 2 by 49. So it is square root 2 by 7. This is one answer, one number you have inserted. Similarly, you can insert the number between 1 by 7 and square root 2 by 7. By using same procedure, you will get square root 2 by 7 into 1 by 7 and whole square root. So this is one of the procedures you can adopt. We will see these kind of terms in the next lectures, that whether it is a there you will come to know what surd is, and we will check whether it is a surd or not. So in place of doing this, we adopt another method. So what we do is, these two numbers are given to us, 1 by 7 and 2 by 7. So we manually divide these two numbers, and we have obtained in our previous lecture, we have seen that the value of 1 by 7 is 0.142857, and value of this is 0.285714. So to find the number between these two, we are looking at the numbers like this. It is 0.142857 and so on. And this number is 0.285714 and so on. Now suppose if I have to write a number between these two numbers, what I can do is, I can write 0. I have to write the number greater than this and smaller than this. So I look at the first term over here, it is 1 over here, and this is 2 over here. It means I have to start the number with 1. It should be greater than this, less than this, so number is 1. Now I look at the second digit over here. It is 4 and this is 8. So I have to write the number greater than this. So greater than 4 is 5 and it is less than 8. So I write 5 over here. So this is a number. But if I will write 0.15, it is a rational number. If I leave the answer over here, 0.15 is a rational number. But the number that we require should be irrational number. So after this, we have to write some digits over here. Suppose I am writing after this, it is 0, 1, 0, 0, 1, 0, 0, 0, 1 and so on. Then this number is an irrational number. You can write any terms after this because we know that now this number 0.15, this is greater than this, and whatever I add after this, it will be less than this number. So this is an irrational number between these two numbers. Similar examples are given over here, that I have written a number over here 0.016. It is another number. Then we are writing 0.218. How we are writing this number? We are saying the numbers we have is 0.14 so on. Second number we have is 0.28 so on. So how we are writing the next number is 0. I have to write 2 over here. Now I have to write the number less than this 8. Suppose I am writing 7 over here. So whatever I will write after this, that number will be less than 0.28 and that number will be greater than 0.14. So this is the procedure how you can write the irrational numbers. If in place of irrational number you are being asked to write the rational numbers, just avoid these dots. If we avoid these dots, the decimal representation will become terminating and the numbers will become rational numbers. Now in the next question, we have to find two rational and two irrational numbers between square root 2 and square root 3. So first of all, we write the values of square root 2 and square root 3. So we have seen over here it is 1 square root 2 is 1.41421356 and so on. And square root 3 is 1.7320508007 and so on. We have to write the number between these two rational numbers. First we write irrational numbers. So it should be 1 over here. 1 is same in both the cases, so it should be 1 over here. Now what we can do, we can write a number greater than this 4. We can write a number less than this 7. So suppose I am writing the number 5 over here and I am writing the number 6. After this, whatever you want, you can write. Suppose I am writing the same number over here. I am writing 1, 4, 2, 1, 3, 5, 6. You can write 0, 0, 1, 0, 0, 0, 0, 1. Repetition should not be there. You can write any of these numbers. All these will be greater than this and less than this. You can write 1.6, 1, 4, 2, 1, 3, 5, 6 and so on. This number will be less than this and greater than this. So you can insert infinitely many irrational numbers. Now if you have to write the rational numbers, the procedure is simple. Don't write these terms after this. Just write it like the answer is say 1.5, say 1.6. Don't put dots after this. 1.5, 1.6. So all these numbers, these are the rational numbers. These numbers are the irrational numbers. So only difference is that irrational numbers, they are non-terminating, non-repeating numbers, and rational numbers, either they are terminating or if they are non-terminating, then they should be repeating. This is the only difference we have. Now in the next question, we have we are given two numbers and we have to write the numbers between two irrational number between these two. So we are saying, we look at the first digit over here, it is 3, it is 3. It means the number we are going to write, it is 0.3. First digit is fixed. Next digit we have over here is 4. And the next digit over here we have is 6. So if I am writing 5 as the next digit, so we know that this 0.35, if I am talking about just this much part, 0.35 is rational and it is lying between these two numbers. It lies between these two numbers. Now what we require is two rational numbers. So what we can do is 0.351. This is again a rational number which lies between these two numbers. If we have to write irrational numbers, then what we have to do, we have to insert some terms over here. We insert some terms over here which are non-repeating. We have to add dots over here which make it non-terminating, and this whole number, this complete number, this will become, this whole complete number, this will become a irrational number. Next we have some true false questions over here. So first is, the sum of two rational number is rational. So this statement is true. If two rational numbers are given, 3 by 4 plus 7 by 8, the answer you will get it is rational. The sum of two irrational number is irrational. This is false. This is not always true. We are saying if we are adding, say, square root 2 and square root 3, the answer is irrational. But if I am adding 2 plus square root 2 and 2 minus square root 2, then the answer is rational. The product of two rationals is a rational number is true, but the product of two irrational is false. Square root 2 into square root 2, the answer is 2, which is rational. The sum of a rational number and an irrational number is irrational. This is true. We are saying if we add 2 and square root 3, the number is irrational. The product of a non-zero rational number and an irrational number is a rational number. This is also a false statement. Why this is a false statement? We are saying if we are having a number a which is rational and we are having the number b which is irrational, so we will get the answer like this. You can get the answer like 3 by 7 into pi. You can get the answer like 4 by say 11 into cube root of 7. So these all numbers, these are irrational numbers. This is important over here. We are saying it should be a rational number. Next is, every real number is a rational number. The definition of real number we will see in the next lecture. So these next two questions, these are the part of our basically the next lecture. And an important question to note over here is, pi is irrational and 22 by 7 is a rational number. So we are saying 22 by 7 is an approximation to pi. It is not an exact value of pi. This thing you have to keep in mind, that 22 by 7 is not an exact value of pi. It is just an approximation of pi. 22 by 7 is a rational number, whereas pi is an irrational number. Up to certain digits the values match, but after that pi is non-terminating and non-repeating. whereas 22 by 7 is terminating and repeating. Now in this last slide, this is not the part of your syllabus, this is just for your information purpose, that if some number is given to us and we have to check whether it is prime or not. Prime means which has exactly two factors. We have to check whether the number is prime or not. What we are going to do is, suppose the number given is 571. So what we have to do, we have to check whether this is divisible by 2, 3, 4, 5, 6, so on. Up to which number we are going to check it. I am going to talk about this. So what this method says is that you calculate the square root of 571. The approximate value is 24. So we will just check up to 24. We need not to check up to 100, 200. We need not to check whether it is divisible by 100 or not. We need not to check it is divisible by 218 or not. We need not to check all these numbers. What we have to do, we have to check only for divisibility with 2, 3, 4, 5, 6, 7, 8 up to 23. And moreover, you need not to check it with 4, you need not to check it with 6. Why? Because if it is not divisible with 2, it is not divisible with 4. So what we have to do is, we have just to check the divisibility with the numbers less than the prime numbers less than the square root of that number. So what we have to do, we have just to check the divisibility with 2, 3, 5, 7, 11, 13, 17, 19 and 23. If this number 571 is not divisible by all these numbers, then it is a prime number. You need not to check with all the numbers, you just need to check with these numbers. If it is not divisible with these numbers, then it is a prime number.